Hi everyone. We are still on mechanics, but today we are going to look at vectors. What is a vector? We sometimes try to explain vectors by first mentioning what a scalar quantity is. A scalar quantity simply is something that has a size, to say, a magnitude. It has a size. You look at something like a distance. You just say 10 meters or 30 kilometers. It doesn't specify from where to where. And you look at speed, the same thing. It's just the speed of the car, speeding. It's just a magnitude they give you, a size. And the mass, say the mass of a person, 80 kilogram, 80 kilo. That's just it. But when we say vector, it goes beyond that. A vector has both a quantity, that is a size, a magnitude, and direction. It specifies which direction that mass is acting upon. For example, you have velocity. Velocity has a magnitude, it also has a direction. Displacement is the same thing. A force, you apply force on something, it must come from a direction or going towards a direction. So that is the difference between a scalar and a vector quantity. Vectors are normally represented by arrows. That is to show the direction. A line like this, for example, this could be a vector. It has this arrow. If you say this is 8 meters, for example, so that is the distance of this vector, and the arrow is pointing towards this direction. If you now have another vector like this, pointing this way, you can now say this is 16 meters, which is twice of this, and it's pointing in the opposite direction. These are both vectors. One going in that direction, the other one going towards an opposite direction. But you represent that by arrows. These arrows explains that. And from there, we will move on to the unit vector. The unit vector, which doesn't include these arrows, but it has some other components to represent the x and y axis. Then from that stage, we move on to a position vector. A position vector that describes the position of a point in relation to the origin. And at each stage, we shall solve problems and see what this is composed of, what it comprises. Now let's look at a problem here. The problem says a man walks 52 meters east, then 69 meters south. How far is he from his starting point and on what bearing? First, you draw a diagram. It helps a lot. So we have our cardinal system. This is the north, this is the east, south, this is east, west, this is south. This is our north pole, to say, this is our east pole, south, west. Right? So in this problem, we are told a man walks 52 meters east. So he was coming to this direction. 52 meters here.
Speed.
52 meters here. East. Yeah? Then 69 meters south. And then it goes south. That it goes down. 69 meters south. $69 south. How far is he from his starting point? And on what bearing? So now we're going to find the resultants of these two distances. Go to join. His starting point is from here. It comes to this point, change direction, and now went south. So now we go to join. As you know, these are vectors. You shouldn't forget the arrows. So now we're going to join these two vectors, this one and this one, from the starting point. This is what we get. It's not perfect, but let me try again. Okay, let's just join it here. Let's say this one starts from here. Correct? And this is the starting point. Okay? So if you join that one, that's the resultant vector now. That's the resultant vector. And the question says, how far is he from his starting point and on what bearing? So because he's moving from this position here, from this starting point, the bearing is going to be from here. That is the angle. Because he comes here, went down this way. When we draw the resultant line, so you can see there's a space here. This is automatically northeast, so it's 90 degrees. But from here to here, from where our resultant force is, there's an angle there. We need to find that angle. That is his bearing from his starting point. But the first part of the question says, how far is he from his starting point? How far is he from his starting point? That we need to find this one here. If we represent this by P, we need to find this distance. He started from here. From here, he came this way. And now they want to know how far is he from his starting point, from here to here, this line. So, if you can just see this is a right angle triangle. And any right angle triangle problem can be solved using Pythagoras theorem. Pythagoras theorem, right? So now we have this. This is our hypotenuse. This is the longest side, or the side opposite the right angle is a hypotenuse. So we have this P squared equals the sum of the squares of the other two sides. We have 52 squared. I'll write it like this. We are using Pythagoras, yeah? Pythagoras theorem. We now have P squared equal to 52 squared plus 69 squared. Let's use a calculator to evaluate those values. We have 52 squared, which is 2704, plus 69 squared, 4761, adding those two will give you 2704. 7465. We want P, not P squared. So you find the square root of 7465. It's P you want, yeah? Not P squared. So you find the square root of 7465 also 86.4 meters. It is to three significant figures. 86.4 meters. So that answers the first question here. How far is he from his starting point? It's this line here. And on what bearing? Now we want to find this angle, theta. So again, this is a right angle triangle. You can use the trigonometric identities to find this angle here. Now we have all three values for the three lines. So you can use any of the trig identity. Use the sine, use the cosine, use the tangent, which one you feel comfortable. But the advice is it's better you use the identity to make use of these two lines, because these two values are given to you. This is a calculated value with you can see it is an estimated value. It was 86.4007 something. So it's better use the values given. And the other reason again, you might have made a mistake. It's a calculator you're using. With this value, this might not be the correct answer. Maybe it's 85 point something or something else, but you wrote this one. So it's better use the values that are given to you in the question. If that is the case, you have, this is your angle here. You have your adjacent and you have your opposite. So which identity should you use? Use the tangent. Tangent gives you an opposite and adjacent. So you have now the tan of theta equals, which is opposite, which is 69 all over opposite over adjacent, which is 52. Yeah, and 69. But you want theta, not the tangent. You want this angle. So theta is equal to the arctan of 69 all over 52. This is what you are looking for. So 69 all over 52 is what? 69 divided by 52. 1 point. Arctan 1.3269. Let's stop there for decimal places. Yeah. So now theta is equals to, let's find that arctangent. Arctan 1.3269. We got 52.999.997, let's say so, degrees. This is what you got. That's your theta. But you are asked to find how far is he and from his starting point and on what bearing. When you are doing bearing problems, solving problems on bearing, the measurement is always taken from the North Pole to say, and it's going clockwise and it's positive on that side. So if you are taking our measurement here from the North Pole, this is starting point here, we take the measurement from here to here. This is 90 now. From here to here is 90 degrees. Then you have plus this one here, what you have just found, 52.997. So the bearing they ask us to calculate the final bearing now, let me call it theta dash. It's going to be 90 degrees plus this bearing we got 52.997 degrees. And again, bearing is given in 3 digits because you know the circle is 360 degrees, 360. So bearing is given in 3 digits. If, example, they ask you to write 10, bearing of 10 degrees, you write it like 0, 1, 0. If it is 100 or 120, 125 to say, it's written like this. It's 3 digits. Okay. So now let's solve this one. Let's just add this one. So this is 90, 52. This is going to be 142. 142.997. So let's just round up. So this is going to be 143 degrees. So that is the answer. Thank you for watching.